Welcome back. We're going to continue our study on the solar system by looking at the moon today. People have stared and studied the moon for centuries and centuries, and we have some idea about it. We've been there, we've collected samples, we've sent probes, so there's some things that we've looked at. There's numerous people that have numerous theories about the moon, and we'll look at some of those theories today. You're going to see that the diameter of the moon is much, much smaller than the Earth. We've got about 1/6 of the gravity on the moon than there is on Earth, so we have much less. It's a much smaller planet-shaped object than the Earth is. In terms of it being unusual, though, the moon, it's very unusual for a moon of a planet to be so big compared to the planet. Most moons are much tiny little specks compared to the planet that is surrounding. Our moon's enormous, and it has a lot of effects. It affects the tides. There's all kinds of effects. I think it makes kids crazy at school whenever there's a full moon. That's just me. Okay, so here's just some specs here. You've got a diameter of about 2,000 mile diameter. Again, that's much smaller than Earth. Density, it is not as dense as Earth. And that's probably because it has a much smaller core, and the core of Earth is thought to have lots of heavy metals in it. And since the core is much smaller, the planetoid being very small, it's going to be less dense because most of the density of Earth is actually at the core of the Earth. About 1/6 of the Earth's gravitational attraction. As far as anybody can determine, there are no tectonic plates. The convection currents underneath that's causing the inside of the Earth to boil and bubble and move around the continents, there is no evidence of that on the moon. Lots and lots of meteors have struck the moon. There's no atmosphere there, nothing to burn up anything that would strike, and so it just strikes and hits the ground, can cause a lot of damage to the ground. We'll look at that in a minute. This is the current consensus, that the moon was formed as a result of a collision with the Earth, that some ancient time ago, a huge meteor or a comet or something hit the Earth and blew an enormous chunk out of the Earth, and that was the moon. Remember, I want to mention, in terms of when science seems to conflict seriously with faith, that scientists are not in any way relating, say, to the Bible or anything that we would have. They're only looking at what they know, and they see that the moon is smaller than the Earth, that the moon is lighter than the Earth, and that the same rocks exist on both. Okay? Those three pieces of data, that it's not as dense, okay, it's not as big, and that the same types of rocks exist, gave some to believe that this is what happened. It's a theory. Nobody can go back and see what happened, but I wanted to at least mention this. If you look at a picture of the moon, which I'll show you in just a second, you're going to see really light and dark areas. That's what allows you to see the man in the moon. The Maria are the dark regions, and they are not mountainous. These are flat plains, and what you're going to see is that they all are basically one type of rock. They're like the bottom of the ocean. It's a basalt lava, kind of the same lava that would have flowed in Hawaii, real thin lava. And what happens is that the theory is that when things have struck the moon, it shattered the rocks, and magma has come up from below and flooded these plains. And so basically it was almost like a retop on the highway. When you get a new surface, it comes up and kind of oozes out and flows, and then you basically get a polished rocky surface. Has less evidence of the asteroid impact than the other ones that have not been flooded, because I don't know when this would have happened, if it happened, but it would have happened a long time ago. The other thing you see is the highlands, and the highlands just mean mountains. And so you're going to have higher than the plains, outcrops and dusty mountains, all pocked with meteor shells. And then the other thing to remember about the moon is that we only see one side of the moon all the time. As the moon is rotating, and it does rotate, it rotates at exactly the same time that it goes around the Earth, which means it takes an entire month for it to go around its axis. And in the meantime, we only see the one side. As it's going around us, it's always pointing itself the same side to us. So we never, until the moon landings, ever saw the backside of the moon. So here's a good picture. You've got different pockmarks, different craters, and you do have craters in the Maria, in the black region, but lots in the highlands, because that may be older. If these volcanic flows would have occurred, it would have covered up other pockmarks that would have made from asteroids and meteors, etc. Okay, so the mare just means sea in Latin. So they're all named. You have the Sea of Rains, the Sea of Tranquility. That's where one of the moon landings was. You have various craters, lots and lots and lots of craters, and there's a lot of names for these. If you're going to study a crater, essentially just put a bag of flour in a pan and throw a marble in it, and exactly the same thing would happen on the moon. You're going to get at whatever struck the moon, usually just disintegrates on impact and leaves a hole. It could crack the bedrock underneath it, depending on how hard or how big it was, and you end up with a lava flow. That's possible, but a lot of times it's just going to bang into the ground and send out a whole lot of stuff. That's called ejecta, the stuff that's ejected from the crater. And then every once in a while, with one that hasn't been there a long, long time, you'll still see the little lines that come out from it where lots of ejecta kind of landed. And you'll see it kind of looking like a star, rays, like the rays of the sun. And of course, this is the idea that this would have happened more recently than other things, and so younger craters would have been the where you have these rays. You can see here that some of these impacts are enormous and huge and will crack the bedrock. If the bedrock is cracked, then any of the lava that's underneath the bedrock will flow out, and that is the theory where these mare or maria come from. Another term that you're going to need to know is regolith, and lith comes from rock, and regolith is just this surface of the moon. So this is the dirt and dust and rocks of the moon, and it's all kind of a gray. You've got some igneous rocks, which are from these lava flows. Breccias is kind of a conglomerate, like a bunch of stuff glued together, like a brownie, where all kinds of stuff has come together and kind of glued. If you have little rocks there and you have an impact crater, there is enough heat from an impact crater to crush rocks together and form new kind of compound rocks. You have glass, where any silica in the dirt that's been hit by something hot enough to melt that glass, and then lots and lots of dust. And the dust is, very deep. So this is called regolith, and regolith is just the soil of the moon. These are a couple pictures from our last vacation to the moon. We see that, I think the photograph on the right is Neil Armstrong, the first man on the moon. He took a picture of his footstep. You can see all that dust that is in it, basically just packed the dust. That dust is not blowing away because there's no wind. If there's no atmosphere, then there's no difference in heating, nothing to move around, and so the wind won't blow. You're going to end up with these depressions that'll last for ages. You do have large rocks and even huge boulders that could have been cast out of a hole as something enormous struck into the moon over its history. So nice, short, easy lesson. Look at the moon tonight.